Hello, welcome back. I'm Savalian, a software dev slash creative, and today we're going to get back into the game dev with a little tutorial on how to create reusable custom elements for UIToolkit in Unity. And before we get started, I want to clarify which UI system I'm talking about, because Unity has had several, and it's kind of hard to find what you're looking for because they all have pretty generic names. I covered some more of this in detail in my UIToolkit sort of basics tutorial, so I'll be brief here, but I'm going to be talking about UIToolkit, which was previously called UIElements. It's a UI library that Unity is making that works similarly to HTML and CSS, where you have a markup language called UXML, where you define your UI elements, and then a language with selectors and properties and things. Basically identical to CSS, but with some differences around which properties are available, and that is called USS. UIToolkit is currently included in newer versions of Unity, and you can use it for runtime UI. It was only for the editor for a long time, but it's been available for runtime UI since at least 2021, which is when I started using it. The only thing is that it is still in progress, it is not done yet. I've been using it for my game, it's been working well enough for me, and I think it's fine. And so that's what this video is going to be talking about, is creating custom elements for this UI system. The core of what we're going to do is subclass VisualElement, or one of the other subclasses of VisualElement, like the label, the button, whatever. And this is useful for when you need pre-made UI, but you also need that UI to have some custom functionality. If all you need is some UI that you want to load in that's reusable, you don't actually need a custom visual element. You can just use a UI document as a template. So you can create a UI document, in your project anywhere, and then either in your UI builder, or you can load it as a resource in code. You can just load up that UI document and add it to other UI. So I've been using this a lot in my project, especially since I didn't really dip my toes into custom visual elements until very recently. So if you don't need any custom functionality, you can just use that, and it's much quicker and easier, and you don't even need to worry about the rest of this video. But the benefit of making your own custom element is that you can create what is essentially a template, but you can streamline some of the code or add functionality behind the scenes that you won't need to then re-implement everywhere that you're using it. So let me explain with an example. I'm going to use one of my UI elements that I've recently made for this. And basically throughout my game, I have different things with customizable colors. So like vanity skins, things that you could swap to customize, like the creatures or the player like gear. And so there's going to be more than one use case for this, but I want it to look and behave the same in every situation. And what this element looks like is just a group of squares, and each square holds the color, like an image of a color for part of that skin. So because my colors are gradient based, I'm not just setting the background on these, I am loading a small image into each of these squares, and the information for which image to load is coming from a custom data class. Basically what I wanted was the ability to load in this element, this swatch element, tell it which skin to use, and then have it load the images correctly, rather than in every situation where I'm using these swatches to have to figure out like how I'm going to parse the data object. Having this as a custom visual element really reduces a lot of code that I would have had to have otherwise, or rather code duplication. This is just one use case that I have for a custom visual element, but you can do basically anything that you can think of how to write code for. You can make any sort of visual element, you can move things around, you can change things based on different game values, and you can do it all inside this element, so you can just sort of pop it in wherever you need to use it. So we're going to talk about how I built this swatch element, what code I needed to make it work, how you might use these same steps to make your own UI component, and I'll also show you how to get it to show up in the UI builder so that you can drag it into another UI document, because there is some code that you need to tell Unity that it should show up there, and how to use it. So step one is, before you start coding or building anything, kind of design out what you want. This is my first step for almost everything that I do in game. It's, designing things is an important first step. Step 2 is to actually start building the layout of the element. And there are actually two ways you can do this. The way I like to use, because I find it a lot easier to see the result as you go, is to just build a UI document in the UI builder and then load that in the custom element. So it pretty much it's exactly what it sounds like. You create a new UI document, go into the builder, place your elements that you want, and then you use resources.load to load that as a visual asset tree. You can clone the tree and add it to the hierarchy. And one thing I noticed when you do this is that when you load elements from a template like that, it does add an extra layer, sort of like a parent object to the entire thing. And this will interfere with positioning if you want elements to position themselves based on their parent. So what I do to get around this is, instead of using just that top level element, I add a visual element that's called like base element or something right at the top. And instead of adding my cloned tree, I grab that base element and I add that, and it removes that extra layer. So that's just a little tip. So for my color swatch element, I just have that base element and then 4 visual elements, just plain ones that are the right shape and size to be these color swatches. And I've made sure to add an ID to each one so I can change them and add those images in. And then the other way to build the layout of your element is to just build it out in code, which in my opinion is a lot more tedious, but it is an option if you have something specific that you want to build. The way that you do this is by using the add function to just add new elements to, wherever you want. And then you can use like .style to change the styles in code, or you can add a USS class. It's very manual work, but in some cases you might prefer that. But either way, in order to get this working and showing up, you are going to need to create a new C# script. This class will be your visual element. So I have a class here called color swatch visual element. I'm going to make the code big so you can see it easier. And the most important part of this is make sure that your class subclasses visual element. By default, Unity just throws mono behavior in here. We want to delete that and add visual element. And in order to use visual element, you will need to import unityengine.UIElements. And it does use that older name, UI Elements. It doesn't say UIToolkit, which can be a little bit confusing. Now, for building out this element here, first I like to save any constants that I need at the tops. So I want to add the path to the template as a string constant. We'll use that later to make our UI show up on screen. I also have some images I'm going to load for the color swatches, so I have a path to those as well. Depending on what you're building, you may need other values available here. You may need no values at all. It just depends on what you're doing. Now, in order for the element to show up as an option in the UI builder, you need 2 little code snippets. And I'm going to comment some of this out to show you the simplest version of this code that you can have. And then later we'll talk about if you want to add attributes to your element, you will need to do some more stuff down here. At the bare minimum, you need to define 2 public new classes, one called UXML Factory, and this inherits from UXML Factory with 2 type parameters, I forget what these are called, the 2 types, and the first type in those brackets needs to be the name of your class. So mine is called color swatch visual element. You're going to want to put whatever you named your custom visual element class in here, so at the top of the file, whatever that says. And then the second type is your UXML traits class, which we're defining just below. And for now, you can leave this blank, so it's just UXML traits inherits from VisualElement.UXML_traits. And one thing you may see in my code that I'm not totally sure if it is necessary at this point is this preserve tag. I added this because the example I was reviewing added it, but I seem to be able to remove it without any negative consequences. So your mileage may vary. You do need to import the Unity engine.scripting library to use this, and I did put it in a region called UXML just in case, but I tested this afterward and I was able to remove it and it still worked. So this might be an artifact left over from when the UI toolkit was only for editor code, possibly. I'm not totally sure on that, but just a little explanation of why that's there. Now the UXML traits class is how we handle attributes. I'll cover how to do things with this in a little bit, but this is what you would put for a class with no custom attributes, is just public new class UXML traits, inherits from VisualElement.uxml traits, and then it has an empty class body. So we have these two class definitions within our VisualElement class. So I think I forgot to mention at the beginning, but we do want both of these class definitions to be inside the brackets for our custom VisualElement. So for mine, that's within the color swatch VisualElement class. And back to the top of our VisualElement class. So when these UI elements are created, they do actually just use a constructor. This was a little bit weird for Unity because a lot of their Unity things, like game objects and components, need to be instantiated in a very specific way by the engine. The UI toolkit thankfully just uses a constructor, which is a relief because everything else is always so tedious to work with. And so in the constructor we can construct our elements. What I've done is just loaded in that template with resources. It is a visual tree asset when you load it from resources, and then you use clone tree to get an instance of that element. And then because we are, this class is a visual element, we can just do add, just right in the body here, and this will add a child element to this visual element. I've also just added a label here that I don't want in my final element, but I wanted it for demonstration here for something later, so I've just added that, and that's all you need to basically load a template. This is a complete but pretty bare bones custom visual element, and at this point you will be able to see your element in the UI builder. You can add it to another UI document and you'll see it load in. And then also if you want to add it to a visual element in code, you can just use the constructor. You could just do new, color swatch visual element or whatever you called yours and instantiate it right there. You can also use the query function with your custom type in the tags to find elements that you've added and make changes to them. And now the part that's really going to kick things into high gear is adding functionality to your custom element. So remember, well, for mine, I want to be able to update the color swatches just by passing in a creature skin option. So what I've done is made a public function that accepts the creature skin option data object. Within this skin, there are indices for the colors that it contains, so I know which images to load. I'm also passing in another data object that will tell the code which options are for emissive textures, just because I want to display those differently. So in this function, I go through, I load images for each of the colors in this skin, I turn off a swatch if it doesn't have all four, and I just set those images as the background for the swatch squares. In your custom function, you can do whatever you want to do. In fact, you don't need to just have one custom function. You can have as many as you need that all do different things. It just depends on what you're building. I've seen some examples where people will use a custom visual element to set up C# events to allow for some data binding. That's one thing you can do. For my project, I think the bulk of my custom elements will probably be focused around taking in some specific data objects, designed for my game and displaying them cleanly. You could also really get deep into the styling and the animation and build out a more advanced control with its own state, like a custom switch element or a special progress bar. There's a lot you can do with this, and it's up to kind of your imagination and your problem solving skills to figure out what is possible. With this function in place, I've basically got everything I need. So I've added this element to the template for my critter list items. And when I add them to the list, I I use Q, I grab that color swatch element, and then I use the custom function to pass in the skin for that critter, and it all displays correctly. But I wanted to go further and explain attributes because I think those might be really useful to, let's say, some power users of the UI toolkit. And I also found that the documentation for how to add these was a little bit confusing, so I just want to talk through it so other people don't have as much trouble as I did. So let's go back to the code for our custom visual elements where we define the UXML traits class. We want to start filling in the body of that class. So for the sake of this example, remember that label I added? Let's say I want an attribute to let people set the text in that label. So pretty simple, this is just what the label visual element does basically. And the first thing we need inside of our UXML traits class is an attribute description variable of the correct type. So there's a lot of different types here. They all sort of follow this pattern of UXML type attribute description is the name. So I'm going to use a UXML string attribute description since my variable is a string. There's also bool and int and I think color. Lots of different number like long and float. So there's a lot of options for this. Pick the one that's right for you. So you'll define this variable and then in the constructor of that variable you can define a name for this attribute. And this is important. This name represents the name of the attribute in UXML. So it cannot have spaces in it or your element will no longer compile. I made this mistake because I thought that this was the name that shows in the builder inspector. So when I did this, I broke my element. I had to go into the raw UXML and take the attribute out because it was just stuck in this error state. So that's the first thing. This name cannot have spaces. And in order to follow the style guide for UXML attributes, it should be all lowercase with words separated by dashes. That's kind of the format for these names. The other important thing is that your custom visual element should have a property with a getter and a setter to hold this attribute value. I saw somewhere that this name had to match the name of your attribute, but when I tested it with a different name, it did still work. So maybe they changed that at some point. But what it does need is to have that getter and setter, so it needs to be a property so that we can actually update the hierarchy when this value changes. Now in our UXML traits class we have that attribute description and we need to override the init function. The init gives us a visual element, a bag of attributes, and a creation context. And in the body of this function we do want to first call the base implementation. And then we can do things in here to initialize the element based on our attributes. So I just have that one attribute that holds that text, and we want to set the value of that attribute to the property on the visual element. So we have a reference to our visual element, but we need to cast it to the right type. So you can either do a forcible cast with parentheses, or what I've done here is the as keyword, the element variable as the type that I want, and it should do that cast for you. And then on the visual element that we have now in the right type, we want to set that property, whatever we called it. I called mine test string. Very creative, I know. And we would just want to set that to the value of the attribute. And the way we get this value is by using getValue from bag. I'm not really sure where this terminology comes from, bag, but it's kind of fun. I don't know. I think it's fun. So once we set that value, the last thing we need to do is go back to our property and change it so it actually updates the label when it's changed. If you don't add anything into the getter or setter here, your element will show up, but when you change the attribute, it will just stay the same. It won't actually update. So we want the label to update every time this property is changed. So in the setter, we want to get a reference to the label that we've added to our hierarchy and set the text with the new value. I'm being a little lazy here because I know there's only one label on this object, So I'm not using an ID or making sure I have the right label or anything like that. Depending on the hierarchy of your object, you may need to, find an element by ID or find something specifically. But I'm not doing that because this is just a little demonstration. I've also added some more code to show you can do more complex operations. It doesn't have to be as simple as setting some text. So here I'm checking if the text is empty. If it is, I'm just hiding the label. So we can do some processing on this value. We can change whatever we need to change and then do whatever we need to do with our new value. For the getter, I'm doing basically the same thing but in reverse. So I'm getting that label, and then instead of setting the text, I'm returning the text so that the attribute is always up to date. And with all of that in place, we should have a working attribute on our element. So if we go into the UI builder where we have this color swatch element loaded in, we can see if we select it, there is now a text attribute in the inspector. If we change the value in this attribute, it does update the label with the text that we've added. So there we go. Now we can add this element to new UI documents. We can set the colors with that custom function I wrote. We can add more functionality if we need to do something else in the future. It's very flexible. We can use this or change this however we like. And that's why I made this video, so that you now can have the power to make visual elements that do exactly what you want them to do. You're not limited to only using, a specific combination of Unity's visual elements. You can expand your horizon a little bit and make a UI that fits what you need. What I'm probably going to do with my newfound knowledge is build out a couple more screens that are designed to take in my game data, sort of natively, rather than going through all this extra code to pick out the values and plug them into the right spots for each screen that I do that in. So that's what I'm gonna do. Let me know in the comments what sort of custom element you're gonna make. I'm very interested to hear what you're working on. If you did find this helpful, please like and subscribe. I hope this was helpful. I hope you've enjoyed it. I'll be back soon with another video, and I hope to see you there. Bye bye.